Neuroplasticity, a key concept in neuroscience. Neuroplasticity, the brain's amazing ability to change. Neuroplasticity is the brain's remarkable ability to reorganize itself by forming new neural connections throughout life. This capacity for change allows the brain to adapt in response to new experiences, learning, injury, and even aging. Understanding neuroplasticity can have profound implications for education, mental health, recovery from injury, and personal development. What is neuroplasticity? The term neuroplasticity is derived from two words, neuro, referring to neurons, the nerve cells in the brain, and plasticity, meaning malleability or flexibility. Neuroplasticity refers to the brain's ability to change and adapt, both in its physical structure and functional organization, in response to experience. For much of history, scientists believed that the brain was relatively fixed after childhood, with little ability to change in adulthood. However, modern research has shown that the brain is highly adaptable, capable of growing new neurons, strengthening connections between existing neurons, and even rewiring itself in response to learning or damage. Types of neuroplasticity. There are two primary types of neuroplasticity: functional plasticity and structural plasticity. 1. Functional plasticity. This refers to the brain's ability to move functions from one area to another, particularly after injury. For instance, if a particular region of the brain responsible for speech is damaged, nearby areas may take over that function, allowing recovery of some speech abilities. 2. Structural plasticity. This involves the brain's ability to physically change its structure in response to learning, experience, or environmental changes. For example, the brain of a person who learns to play a musical instrument may develop stronger connections in regions involved in motor control and auditory processing. How neuroplasticity works. The brain is composed of billions of neurons that communicate with each other through synapses. When we learn something new or have an experience, these neurons fire, and connections between them become stronger or weaker depending on use. This process is often referred to as synaptic plasticity. Synapse strengthening. When you repeatedly engage in an activity, such as practicing a new skill or studying information, the connections between the neurons involved in that task become stronger. This is sometimes summarized by the phrase, neurons that fire together, wire together. Synapse weakening. On the other hand, if connections between neurons are not used, they become weaker. This is a form of synaptic pruning, where unused neural connections are eliminated, allowing the brain to operate more efficiently. Examples of neuroplasticity. Neuroplasticity occurs throughout life in many different contexts. Here are some common examples. 1. Learning and memory. When we learn new information, such as how to speak a new language or solve a math problem, our brain creates new neural pathways. Over time, as these pathways are reinforced, it becomes easier to recall or perform that task. 2. Recovery from brain injury. Neuroplasticity plays a crucial role in recovery after brain injuries like strokes. In many cases, undamaged parts of the brain can take over functions previously controlled by damaged areas. This allows individuals to regain lost abilities, such as movement or speech, with proper rehabilitation. 3. Habit formation. The formation of new habits, whether positive or negative, is also an example of neuroplasticity. Repeating a behavior strengthens the neural pathways associated with that action, making it more automatic over time. 4. Sensory adaptation. Individuals who lose one sense, such as sight, often experience heightened abilities in other senses, like hearing or touch. This occurs because the brain reallocates resources from the unused sensory areas to strengthen the functioning of other senses. The role of neuroplasticity in mental health. Neuroplasticity also plays a significant role in mental health. For example, therapy techniques like cognitive behavioral therapy, CBT, help people reframe negative thought patterns and behaviors, essentially rewiring the brain. Over time, this can reduce symptoms of conditions like depression and anxiety. In cases of trauma, neuroplasticity can lead to both positive and negative effects. While the brain can form negative associations and responses after a traumatic event, it is also capable of recovery and creating new, healthier patterns through therapeutic interventions. Ways to boost neuroplasticity. While neuroplasticity occurs naturally, certain activities can help enhance this ability and promote brain health. Here are some ways to boost neuroplasticity. 1. Learning new skills. Engaging in activities that challenge the brain, such as learning a new language, playing a musical instrument, or solving puzzles, promotes the formation of new neural pathways. 2. Physical exercise. Regular physical activity has been shown to increase neurogenesis, the growth of new neurons, and improve cognitive function. Aerobic exercise, in particular, enhances brain plasticity and helps maintain brain health. 3. Meditation and mindfulness. Research suggests that mindfulness practices can increase the thickness of brain regions involved in attention and sensory processing. Regular meditation can help reduce stress and improve focus, leading to changes in brain structure. 4. Healthy diet. A diet rich in omega-3 fatty acids, antioxidants, and nutrients like magnesium and vitamins can support brain health and neuroplasticity. Foods like fatty fish, leafy greens, and berries are particularly beneficial. 5. Adequate sleep. Sleep plays a vital role in memory consolidation and neural repair. During sleep, the brain strengthens new neural connections formed during the day and prunes away those that are unnecessary. Challenges and limits of neuroplasticity. While neuroplasticity is a powerful tool for growth and recovery, it does have its limits. Some neural changes, particularly those associated with age-related decline or severe brain injury, may be difficult to reverse. Moreover, not all changes are beneficial. Negative habits or behaviors can also lead to maladaptive neural pathways. Additionally, neuroplasticity doesn't occur at the same rate throughout life. While the brain is highly plastic in childhood and adolescence, it tends to become less adaptable with age. However, with the right strategies, adults can still harness neuroplasticity. Certainly. Here's an educational piece on the fascinating